So we're going to be solving inequalities, and first of all, these definitions, closed interval. It says denoted by, and notice the brackets when you have a closed interval AB. It says consists of all real numbers x, where x is between A and B, including A and B. Okay? No including A and B because they have the bar underneath. Okay? The equal bar underneath. For your open interval, that's going to be denoted with open parentheses. That's all real numbers where x is between A and B. Notice for that one, I'm not including A and B. There's no equal bar underneath the A and B. Okay? And then for half open or half closed intervals, you can either call them half open or you can call them half closed. It's the same thing. That's when one side's going to be open and the other side's going to be closed. Open is like an open circle when you would have a parentheses. Closed is going to be a closed circle, and that's when you have a bracket. Okay, in this notation, that would mean one of them has an equal bar and the other one doesn't. Okay? And then this is just some examples of what the number line would look like, and we've done, this is interval notation, we've done interval notation. You know, it would either be a parentheses or this would be an open circle right here with parentheses. So that would be A to infinity. If x would be between these two values, these are parentheses, that could also be open circles. And in this, when you have a bracket, that could be a closed circle, and parentheses could be an open circle. Okay? So how many questions on that? Okay, so example 1, we're going to do 4 problems. It says, write each inequality using interval notation. Okay. For interval notation, if you remember when we started the year, we talked about interval notation, we talked about set notation. And interval notation was with the parentheses and the brackets, remember that? And the set notation was in the braces and the x such that and all that. You don't have to do set notation. If you want to do set notation instead of interval notation, you can. I think most of you prefer the interval notation. Okay? Now, you don't have to draw the number line for these examples, but I'm going to go ahead and do it so you can see what the number line looks like, and then from there you can get your interval notation. Okay, so for A, first I'm going to draw my number line, and I'm going to plot my point 1 and 3. 1's going to be on the left, 3's going to be on the right. Okay, and it's telling me that x is going to be between those two values. Okay, first of all, do you see that you have equal bar underneath both of them? Okay, so you can either put, I'll give you the option, I don't care. You can either put for the 1 and the 3, you can either put a bracket or you can put a closed circle. Okay, I'm going to use a closed circle, but like on the previous page, I used brackets and parentheses. If you want to use a bracket, you can. But these are both closed circles or brackets. Okay, and then you need to know where to shade. So you need to look at this problem. And usually I read the one on the right first. That kind of helps me determine where to shade. And just this piece says x less than or equal to 3. So if I look at 3, which way is less than, the right or the left? The left. Okay? And if you look at this piece, you don't read it this way, you read it this way. So you actually kind of have to flip the sign around. If I'm reading it this way, it's x greater than or equal to 1. If you read it left to right, it says 1 less than or equal to x. Okay, so if you read it backwards, it's telling you that x has to be greater than 1. So that means you need to shade this way. So it's between these two numbers that I'm going to be shading. Now, your interval notation should be easy to get from this. Because this is a closed circle, is that going to be in parentheses or brackets? Brackets is going to be bracket 1 and going all the way to what? 3. And it's a closed circle, so it should be a bracket. This is your answer. Okay? Again, you don't have to draw the number line unless it tells you to graph it. This one did not say graph, so you did not have to draw the number line. Okay, for part B, I'll go ahead and put a number line here. I'm going to plot the points -4 and 0. Are these going to be open circles or closed circles? Open. Okay, so you have open circle, or you can have what? Parentheses. Okay, so I'm just going to use open circles. And I'm going to go back to my statement, and this one on the right says x is less than 0, so that means I'm going to shade to the left here. And this would say x is greater than -4, so I need to shade in between. Okay, to do your interval notation, I know the smallest possible number I have would be really close to -4, but not including -4 because it's an open circle. So because it's an open circle, how do I start my notation? Parentheses, -4 to what? 0 and then parentheses. Okay, as you can see, x is not between two different numbers. It just says x is greater than 5. So the only number you apply on your number line is 5. Is this going to be an open circle or a closed circle? Open. Open, and greater than is which way? Right. To the right. Okay. So this interval notation is if you start with parentheses or bracket. Parentheses, and what's the first number that goes there? 5, and it goes all the way to what? Infinity, and always next to your positive or negative infinities, you have parentheses. Okay, and then for part D, it says x is less than or equal to 1, so I'm going to plot 1. Open circle or closed circle? Closed. Okay, and it says less than, so which way do I shade? Left. And how do I start my notation?
Open circle.
You always want to start with the smallest number, so we start way over here. What's the smallest number can be? Negative infinity. So I'm going to start with parentheses. Negative infinity goes all the way to what? 1, and we goes after 1. Bracket. Good. Natural. Okay. Okay, example 2 says, write each interval as an inequality involving x. So we're going backwards now from what we did in example 1. Example 1 gave you an inequality, and you had to write an interval notation. Okay? Example 2 gives you interval notation, and you have to write it as an inequality. Okay? Again, it doesn't ask you to draw the number line, but you can graph the curves if you want. Might be easier for you to see what your inequality would be if you graphed it. Okay, I'll go ahead and draw the number line for the first one. Okay, and I know that I'm going to plot these 2 points, 1 and 4. Okay. Okay. Open circle or closed circle where 1 is? Closed. Open circle or closed circle where 4 is? Open. Okay. And you're going to shade in between. When they give you a statement like this, you shade in between the numbers. So you're going to shade here. And so from that, you can get your inequality statement. Okay. You can look at this and see x is between these 2 numbers. Okay. So I know it's between 4 and 1. Okay. Is it greater than or less than 4? It's less than, so I need to have a less than here. And because that is an open circle, you do not have an equal bar underneath. Okay? Is it greater than or less than 1? It's greater than. So the symbol looks like a less than, but you need to read it backwards. It's greater than. It can also be equal to. Okay. So because it can also be equal to 1, because of being a closed circle, we put an equal bar underneath. So that is your interval notation, or your inequality symbol, written that way. Okay? Anybody have a question on part A? Okay, let's try part B without even having to graph it. Okay? What would part B look like? If this is an inequality statement, what would it be? X is greater than 2. Okay? Because if you can try to picture what this number line would look like, okay, it says I'm going from 2 to infinity. There's a parentheses here, so it would be 2, open circle, and they go all the way to infinity. Okay? So that statement would be x is greater than 2. Okay? Yep. This would have been a bracket for it to be greater than or equal to. Okay? Okay, let's try to do C without going the number line. You see how you have 2 numbers? Anytime you have 2 numbers, your x is going to be between those 2. See how this one did not have 2 numbers in part B? Part B had a number and had an infinity. So it's just going to be greater than equal to, or less than equal to. But when they have two numbers like you did for part A, your x is going to be between those two numbers. So it's going to be between 2 and 3. Okay? For it to be between those two, it's going to be greater than or less than 3. It's got to be between them. So it's going to be less than. And I have a bracket, so it needs to be less than or equal to. And it being between 2 and 3 is going to be greater than or less than 2. Greater than. So reading it from the right to left is going to be greater than or equal to. Okay. Okay, and let's try to do part D without going the number line. Okay, notice there's only one endpoint. Okay, smallest value it can be is negative infinity, so you should be able to kind of picture what this would look like on your number line. Okay, so that means at negative 3 you have a closed circle. Everything to the left would be shaded. So how do you make that inequality statement with x? X is less than or equal to this negative 3. Okay? Okay. Example 3 says solve the following inequalities and graph the solution set. Okay? So we're solving equations, just our equations have an inequality symbol, and after you solve it, you have to graph it. Okay? Okay, so part A, you want to graph these just like you graph regular equations. The only difference is when you're graphing or when you're solving for inequalities, you have to pay attention to when you multiply or divide by a negative. Because what's going to happen in your problem if you multiply or divide by a negative? Your sign's going to flip around. Okay? So it's the only thing you need to watch for when you're solving these equations. So for part A, to start solving for x, what would you do first to get x by itself? Subtract 3. Okay? Now don't lose the negative in front of 2. This is negative 2x. Is less than 5 minus 3 is 2. Okay? And to solve for x, now you have to divide both sides by negative 2. You are dividing by a negative. So because you're dividing by a negative, this becomes x is greater than negative 1. Okay? So we solved it. X is greater than negative 1. Now we have to graph it on the number line. So on the number line, we're going to plot negative 1. Is it going to be an open circle or a closed circle? Open circle. And do I shade to the right or to the left for greater than? Right. To the right. Okay. That graph is part of your answer, so on your homework, I do need you to box in the graph part also. Are there any questions on part A? Okay, for part B, there's more than one x. Okay, there's an x on each side of my inequality symbol. So I'm actually going to move all my x's to one side and all my other numbers to the other side all in one step. Okay? To keep my x's positive, I'm going to move them over to the left. So I'm going to subtract 2x. And that'll get rid of the x's on the right side. But now I want to get rid of the numbers on the left side. So I'm going to subtract 7. And so I get 2x is greater than or equal to negative 10. Solve for x, divide by 2, and so x is greater than or equal to negative 5. Okay, so that is the solution. Now we need to graph it on the number line. So to plot negative 5, is that going to be an open circle or a closed circle? Closed circle. And which way is greater than? Right to the right. And that's your other answer. Okay, example 4 says solve the following combined inequalities and graph the solution set. Okay, it's called a combined inequality because you actually have two inequality statements pushed together to make it look like one. And there's more than one way to solve this. I'm going to show you two different ways, and then you do whichever way you want. Okay. You can actually take this problem and separate it into two and solve each one by itself and graph it, or you can do it all at one time. Okay. I like to do it all at one time, but I'm going to show you how to separate it first, because sometimes people look at this and it looks confusing. It's just too much stuff. Okay. So if you want to separate it first, you can do that. So if you separate it, this is one problem. Negative 5 is less than 3x minus 2. Okay. And then this is the other problem. 3x minus 2 is less than 1. That middle part goes with both pieces. Okay? So if you solve each of these individually, starting with the one on the left, try to get x by itself, so I add 2. And divide by 3. So I get negative 1 is less than x, which actually reads x is greater than negative 1. Okay? You don't plot that yet. You need to go ahead and do the other problem first. Then you can plot it together. So to solve this one, add 2. So I get 3x is less than 3. Divide by 3. So x is less than 1. Okay? So on your number line, you need to plot these things together. Okay? And you can actually see, you can put it right back together as an equality statement. Negative 1 is less than x is less than 1. So that's your equality statement if you want to put it back together. And on your number line, you're going to plot those 2 points, negative 1 and 1. Open circles or closed circles on those two. They're both going to be open. Okay, and then pay attention to your statement. It says x is less than 1. So which way do I shade for 1? On the left side. And then this says negative 1 is less than x. And turn it the other way, x is greater than negative 1. Which way do I shade for that one? To the right. So I'm shading in between. Okay, so we solved it. And we graphed it. Yes.
So you don't change the sign, but you divide it by negative 1?
Not unless you divide or multiply by a negative 1. Okay? Just adding or subtracting, this will change sign. It's only going to be when you multiply or divide by a negative. Okay? Any questions on this one? Okay. Okay. And this is B. Doing the same thing. You're going to solve this inequality. Oh, I didn't show you how to do the other one as one. Let me go back. Let me go back for just a second. Let me clear this off and do it as just one inequality. Okay, this time we'll do the next one. So this one I broke it down into 2. Okay, now I'm going to do it and I'm just going to solve it as one inequality. So looking at this middle piece, it's x, which you need to get by itself. Okay? And there's actually 3 parts here. Not like a regular equation where there's just 2 sides. There's actually 3 parts here. So you're going to get that x by itself, but as you do that, you have to make sure you're doing the same thing to every single piece. Okay? So for this one, I'm trying to get x by itself, so I know I need to add 2. Okay? If you're adding 2 there, you have to do it to the other 2 sections. Add 2 here, and add 2 here. Okay? So this will go away. You have negative 3 is less than 3x is less than 3. So do I have a question on that step? Okay. What do I need to do now to get my x by itself? Divide by 3. And you have to do it to every single piece. So I have negative 1 is less than x is less than 1. And that's the same statement I had before whenever I separated it. Okay? So that will be your solution. And you can graph negative 1 and 1. You know they're going to be open circles. And they're going to be shaded in between. Okay. Any questions on this one? Okay. So I'm going to do this one as it's just one equation. Okay? As one problem. I'm not going to separate this one. But if you want to separate it, that's fine. Okay, if I'm trying to solve this equation for x, what is the first thing I need to do? Multiply by 2, because this is divided by 2, you want to multiply by 2, and you have to do that to every single piece. Okay? So that 2 is going to disappear, it's going to cancel. And you have negative 2 less than or equal to 3 minus 5x less than or equal to 18. Okay, what do I need to move next to get 5x by itself? Subtract the 3. Again, remember to do it to every single piece of your problem. So this will be negative 5 less than or equal to negative 5x less than or equal to 15. Okay? And your last step to solve for x is to divide everything by negative 5. Now you're dividing by a negative, so make sure that you change all of your signs. Okay? This is going to be 1, and that's going to change from a less than sign to greater than or equal to. These cancel, so you have x. This is going to change from less than to greater than or equal to. And 15 divided by negative 5 is negative 3. Okay? So that's an answer. And then you have to graph it. Just notice for this one that it's kind of backwards, because for all the others, your smaller number was on the left and your bigger number was on the right. This problem, the bigger number is on the left and the smaller number is on the right. You still know you need to plot those two numbers. So I'm going to plot negative 3 and I'm going to plot 1. Are those going to be open circles or closed circles? Closed circles. Okay? And like I said, I like to read this one first to kind of give me an idea of which direction this needs to be shaded. This reads x is greater than or equal to negative 3. So which side of negative 3 do I need to shade, the right or the left? You need to shade to the right. Okay? And then this says 1 is greater than or equal to x. If you read this way, x is less than or equal to 1. So which side of 1 do I need to shade? The left. So this is your graph. Okay? Now, any questions on that? Because your graph is not always going to be shaded between those points. So I'm going to show you one when it won't be shaded between the points. Okay? I'm just going to change this to say negative 1 greater than or equal to x greater than or equal to 3. Okay? Let's say that's what we came out with in our problem. Okay? Just so to make sure that you just don't automatically shade in between. It won't always be that way. Okay, if I plot these points, negative 1 and 3, I know they're going to be closed circles. And I'm going to read this one first. What does this say? X is greater than or equal to 3. So which side of 3 do I need to shade? To the right. Okay? And then what would this piece say? X is less than or equal to negative 1. So which side of negative 1 do I need to shade there? To the left. Okay, so just pay attention to your signs right here. That's why I like to look at this one first. If this is going to shade over there, then the other one's probably going to shade to the left. Okay? So just pay attention to that sign, because they won't always be in between. Sometimes they'll be away from each other. Okay? And just for practice, to review, how would this implementation go? How far to the left does that graph go? So be parentheses, negative 50 to what?
Negative 1, bracket.
Bracket. U for union, good. And then what? Bracket. 3. Good. You remember something to this stuff.
When I put
Okay.
those brackets whenever it was like all the way, like whenever it's positive or something.
It's brackets whenever this is what? It's brackets when you have closed circles. So you like to have a closed circle on 3, so the next to 3 I'll have a bracket. And I have a closed circle from negative 1, so next to negative 1 I have a bracket.
I felt like for the infinity though, like before.
The next sentence is always a parentheses. Always. Okay? Okay, this is your homework. I'm going to give you a worksheet, and you'll do this for the rest of the hour. It's 1 through 18 all.